Okay, so just wanting to go through earliest possible and latest possible start times briefly. Um, Up the top, we have a beautiful, neat drawing of earliest and latest possible start times. That's what it'll look like if it comes at you in question form. So what I've done is I've rewritten it so it's got spaces for us to put in the earliest possible start time and latest possible start times. So let's work from left to right, putting in our earliest possible start times. We've started our whatever activity it is, and we're moving through the first stage to get to stage 1. So the starting stage takes 13. There's no way we can start the next stage any earlier. So here's stage 1, and this is what I want to explain, is the numbers up here to me are like stages, whereas these individual little lines are activities that help us get to the next stage. So in order to get to stage 2, I'd have to do just this one activity of 12 hours. So there's no way around it. That'd have to be 25. To get to stage 3, again, there's no other activities. So we just go from the 13 hours in, hours, days, minutes, seconds, whatever. I've just decided it's hours for this one. So 13 hours in plus 9 would make us 22. And then 13 plus 15 makes 28. Unless I'm very wrong. Pardon my pen is being weird. 28. Okay. Now, from 2 to activity 5, sorry, from stage 2 to stage 5, there's 2 different activities that need to be completed before we get to stage 5. So, of course, 25 plus 17 is 42. So we might have 42 in here. I'll just check down here. 22 plus 7 is 29. So the earliest possible start time is when both of these things are done. So 42 is going to take longer. That is our earliest possible start time for activity 5, because we must wait for all these connected activities to finish. Alright, so then going down to here, again, we've got 2 activities coming together before we can start stage 6. So 22 plus 14 is 36. So it could be 36. Let's just check. 28 plus 13 is 41. Unless I'm madly mistaken. Yeah, 41. So this is the larger path. We have to take the larger path, 41. Okay, so then these 2 coming together. Oh dear, I haven't marked in. Let's just quickly correct that. This is I6. And this is J10. So then the shortest possible path this time, 42 plus 6 would be 48. 41 plus 10 would be 51. We must take this pathway 51. And then the last pathway says, okay, takes 4. So to get to our finish line, we've just got to add another 4 hours to that and make a total project of 55 hours, minutes, days, seconds, years, whatever it is. Now, let's backwards map this. The finish time has to be 55, because the critical path, which we haven't identified yet, the critical path has determined that this whole project will take 55. Unescapable, inescapable. So working backwards from there, we can take 4 hours off to get to 51. Now it branches. So 51 is our latest possible start time for stage 7. Our latest possible start time for stage 5 would be 51 minus 6, which would be 45. So now we can see a gap starting to occur. This is our float time for activity I. And we'll return to that in a moment. If we go this way, 51 minus 10 would be 41. We can see our critical path starting to emerge, because there's no play time here. There's no twiddling your thumb times at all. Alright, from 41, we're going to go backwards this way because this one's more straightforward. 41 minus 13, 38, 28. Oh, again, we can see no float time there, so our critical path is becoming secured. 28 minus 15 will be 13. And because that matches this, and there's no float time, this must be 13. Any other numbers will probably be higher. Any other numbers coming from here will probably be higher, so we can ignore them. We have to take the number that is smallest, and I'll return to y in a moment. This might be a good example right here of why we have to take the smallest number. Alright, if we follow this pathway back here, 41 minus 14, 37, 27. Alright, so I'm just going to note that here. And this is something you might want to do in the exam. You just note. Going back this way, going back that way creates the number 27. 41 minus 14 is 27. But going back from this way, 45 minus 7 is 38. Which one do we use? Now remember, what we're finding here is the latest possible start time of this stage of the project. This stage of the project. Each of these activities then have their own little bit of time, and they could be the same, they could be different, they could be going off into various places. But let's have a look at these two numbers. If I started at 38, if I put 38 in here as my latest possible start time, what would happen? Alright, 38 plus 7, I'd be fine, I'd be on 45. I'd still be on target to finish on time. But if I put 38 in here from here, 38 plus 14, 48, 52, I'd be over time. I'd be way over time. If I went 38 plus 14 is 52, then 52 plus 10 would make 62, 62 plus 4 is 66. The whole project has been slowed down by this branch here. So out of these two numbers, I have to take the lower one, because the lower one then keeps this critical path on track and everything else flows along. So just as a note, when you're in that exam or you're trying to do these quickly, just look at the lower of the two numbers when you're backwards scanning, and that will be the one that has to then define what goes in there. And making notes on your little drawing will really help you to identify which numbers go where. Also, this will help us find float times later on. This number here will help us find float times later on. Okay, so going backwards from here, 45 minus 17, what's that, 38, 28. Alrighty, I believe that's backwards mapping done. Yay.